This video is going to take you pretty quickly through the notes on operations with polynomials and polynomial functions. Specifically, we're going to be looking at the operations addition, subtraction, and multiplication. First, let's talk about addition with just regular numbers. I think you could all pretty quickly tell me that 5 plus 6 is 11, and 6 plus 5 is also 11. So addition is what we call commutative. That means the order doesn't matter. And that holds when we add polynomials as well. Let's look at an example of adding two polynomials. Here I have polynomial 1 in parentheses, polynomial 2 in parentheses. Now, addition is really nice, and it's actually just combining like terms. We don't have to do anything special. We'll start by adding 4x to the third plus, well, we don't have anything with x to the third over here. So that 4x to the third is actually just going to stay the same. Now I have negative 4x squared, and over here I have a plus x squared. So that's going to be negative 3x squared. Remember, when I add like terms, all I do is change the coefficient. The variable and the exponent stay the same. Next, in the left polynomial, I have an x, and then in the next one, I have a negative 3x. And so I'm doing x plus negative 3x. That will be minus 2x. And then now I'm just looking at my constants. I have negative 10 plus negative 1. That's going to give me a negative 11. And that's my final answer. I added two polynomials separated by parentheses, and I got one polynomial, one new polynomial. Operation with polynomial functions isn't actually going to be any different. It's just the notation that's a little bit different. Rather than writing out the individual expressions, I'm going to write it using the names of the function. So I'm going to use f and g. So one way I could do it is I could ask, well, what's f of x, the function f of x, plus the function g of x? And that's saying nothing different than take this first expression and add the second expression. Another way to write it, instead of these two separate x's, is actually just to write f plus g. I'm adding function f and g. And then this is making a brand new function, which is a function of x. So we really only need the x once. What this is going to represent is this plus this. And I could write that out. It takes a little bit of time. Negative 2x to the fourth, parentheses, plus 6x squared plus 12, plus 3x to the fourth minus 3x squared plus 4. But I'm pretty sure you guys could have done this in your head, just referencing those top functions. So what's this going to equal? Negative 2 plus 3 on my x to the fourths. That's going to be x, just x to the fourth. 6x squared minus 3x squared plus 3x squared. 12 plus 4 plus 16. And this is a brand new function, f plus g of x. And its name is f plus g of x. Subtraction is pretty similar, but there's two things we're going to have to watch out for. One is going to be our sign, and the other is going to be that order actually is important. You guys could pretty quickly tell me that 5 minus 6 is negative 1, but 6 minus 5 is just positive 1. So subtraction is not commutative. So you need to be very careful which polynomial we're subtracting from which polynomial. Our second problem is going to come when we actually look at the two polynomials lined up. I have my first polynomial, and then I'm subtracting my second polynomial. I'm actually going to talk you through two different ways to solve this problem, and you'll pick the one that you like the best. So the way I usually do it is I actually rewrite this whole expression without the parentheses, but I have to be careful when I do that. So let's start. I can recopy the first polynomial, 4x to the third minus 4x squared minus x plus 10. I can copy that perfectly the way it is, but things have to change when I copy over my second polynomial. This whole thing is being subtracted. It's almost like I'm multiplying it by an invisible 1, but it's negative. So every sign is going to change. So I'm going to be subtracting x squared, and then negative 1 times positive 3, I'm going to be adding 3x and adding 1. And now that my parentheses are gone, I'm doing it just like addition. I'm just combining like terms. So my 4x to the third doesn't have a pair, so 4x to the third is all alone. Then I have minus 4x squared minus x squared minus 5x squared minus x plus 3x plus 2x, and then plus 10 plus 1 plus 11. And that would be my final answer. Now let's quickly go through a second way to do this, and that's actually to line up the problem. So I would have 4x to the third minus 4x squared minus x plus 10, and then I'm subtracting. I'm going to write my other polynomial under here, x squared minus 3x minus 1. This subtraction sign reminds me to always go back to subtraction. So I've got 4x squared minus, well, I didn't have anything to the third, so that just stays the same. And then I have negative 4x squared minus x squared. So that's going to be negative 5x squared. And then I have minus x minus negative 3x. And you know that when you minus a negative, you actually end up adding. So that would end up being positive 2x. Now I have plus 10 minus negative 1. So that's going to become plus 1, so plus 11. And you can see we got the same answer. And they're pretty much the same methods, but you can pick your favorite. All right, so let's look at it with polynomial functions. Again, very similar to addition, we're going to have two ways of writing the problem. Now, if you're looking at your note sheet, I've asked you for both f of x minus g of x, or f minus g of x, and the other way around. So make sure you're writing this down in the correct spot, but I'm only going to do one for the interest of time. So make sure you're writing this where it says f minus g of x. And again, as I mentioned, we have those two notations. We could say f of x minus g of x, and we could find that. Or more commonly, you'll actually see the two names written together followed by just one x. Again, for the sake of time, I've copied the first, I've called it f of x right here, and g of x right here. And I'm subtracting them. Now I've also gone ahead and recopied f of x right here, because I know that polynomial doesn't change. Now I know when I recopy g of x, I have to flip my signs. So I'll have minus 3x to the fourth plus 3x squared, flip that sign, and then minus 4. So I also flipped that sign, and that one right there. Cool, and now I'm just combining like terms. Negative 2x to the fourth, negative 3x to the fourth. That's a negative 5x to the fourth. 6x squared plus 3x squared. That's 9x squared. Then 12x minus 4, that's plus 8. So my final answer here is a brand new polynomial function, f minus g of x equals done. All right, our last operation now is multiplication. And this one's also going to seem quite familiar. It's very similar to that process that we learned called FOIL. Except that acronym is not going to help us now that I'm going to try to multiply a trinomial by another trinomial. But it's pretty much the same idea. What I'm going to do is I'm going to start with the first term of the first polynomial. And then I'm going to multiply that by each of the terms in the second polynomial. So I'll do x squared times x squared, so that's x to the fourth. X squared times x, x to the third, x squared times 1, plus x squared. So now I'm done with that first term. Now I'm going to take the second term in the first polynomial, and I'm going to multiply that by each of term in the second polynomial. So 3x times x squared is 3x to the third. 3x times x is 3x squared. 3x times 1, just 3x. Now I'm almost done. I'm going to take my last term in the first polynomial, and I'm going to multiply that with each term in the second polynomial. So I've got minus 2x squared, minus 2x, minus 2. And now if I had more terms in the first polynomial, I would continue doing this, taking each term in the first polynomial and multiplying it with each term in the second polynomial. So now I've got this long string of stuff, and I've got to combine my like terms. So it looks like x to the fourth doesn't have a pair, so that's all by itself, x to the fourth. And then I have an x to the third here, and an x to the third here, and that looks to be it. So 4x to the third. Got an x squared, x squared, x squared. Make sure you keep all the signs. So 1x squared, 3x squared, minus 2x squared is going to be plus 2x squared. And then I have a 3x and a negative 2x, so that's just plus x. And then I've got this minus 2 all by itself. So here's my brand new polynomial. Now I'm not going to do the multiplication of polynomial functions. I think by this point you guys can figure that one out by yourself. So good luck and do all the practice problems. Ask me for help if you need any.